All right, so before I get into this next video, I'm here in my office at my house, and there's a couple things that I wanted to correct in the video before I get into it. I did some research once I got back in the house, and so what I wanted to tell you is during the video, I mentioned something about the temperature of the magnet. Um, the wire that I use, the insulation, has a rating of 194 degrees Fahrenheit or 90 degrees Celsius. Um, and something else I mentioned was at some point I'm looking to build a magnet with about a 6-inch core, hopefully about 5,000 feet of wire. So I wanted to let you know a couple specs of that magnet if I was to go through and make that. So at 5,000 feet at 12 volts, it would draw roughly 0.6 amps. 24 volts would be 1.2 amps, 36 volts would be 1.8, and 48 volts would be 2.4 amps. Something else I wanted to point out in the video is I make references to flyback diodes. I was unsure if my terminology was correct, and it actually was. I'm surprised that I remembered that off the top of my head. And I mentioned I got a brand new circuit breaker. Part of the video I stated that it was a 200 amp. I was wrong. I corrected that a little bit later, but it's actually a 150 amp circuit breaker. And I know that I'm going to get some flack. There's a lot of people who use solenoid and relay interchangeable, and I will try to clear that up real quick. So basically, a relay uses an electromagnet to connect contacts within the relay, thus energizing another electrical circuit. A solenoid is a form of electromagnet that is used to move a metal rod, which turns the magnetic field into a form of mechanical energy or mechanical force, I guess is the correct terminology. I just wanted to put that out there before we get into this next video. I reference another video multiple times in here that is going to be on my channel. I am going to upload that. So if you aren't sure what I'm referring to, go check out the other video, and hopefully you'll be able to get a better understanding. Let's get into this video.
Hey, it's Cam, the Mad Redneck Scientist. So I've taken a break from the ZX10R go-kart for a little bit. I'm going to get back to that. Just a little side note. So I'm going to show you something that I'm working on here. For any of you that know me personally, and those of you who don't know me personally, I did a lot of scrap metal, recycling, property clearing, stuff like that. I'm self-employed. Did all that before I found out that we were moving. Well, I created a giant electromagnet out of microwave transformers. I'll show you guys that probably in another video, explain how I did it. But it turns out that wasn't really strong enough for what I needed to do. On top of that, the coils were aluminum coils. I thought they were copper, so I had to be a lot more cautious about heat. As aluminum has a lower melting point than copper does, especially the enamel coating. So a different magnet here. So this is the magnet. It's approximately 8 1/4 inches across. Overall, it's about 5 inches tall. The actual coil inside is about 8 to 8 1/4 inches in diameter. It's about 3 inches tall. There's 1,000 feet of 14 gauge solid strand wire. As you can see, there's some of it there, and let's see here. And you can see there's some more there. There's roughly 716 what's called amp turns, or complete rotations of wire around this core. The core, as you can see here, is a 2-inch solid steel rod. It's just mild steel. The top here is I think it's 1/8 inch mild steel cap, and the outside here is actually a portion of a old I think it's a 200 CF oxygen tank that I basically cut down since it was perfectly round, used it for a core. There is a bit of plywood along the top, as you can see right here, to help isolate the wire from the top plate. And as you can see, there's a piece of plywood on the bottom. So after my calculations, at 12 volts, this should pull roughly 4 amps. So I moved up from the 14 gauge to an 8 gauge wire up top to feed it. The wire runs over to 2 batteries. This is also just a temporary setup. But I did a test, found out 12 volts was not enough. I could stand on a steel bar and it would pull it off the magnet. So as you can see, I have these batteries run in series, and I'm running 20.79 volts. They're not fully charged. But let me explain here. So I have the positive lead from one battery. This lead goes out to the magnet. The negative lead of the same battery comes across to the positive lead on the second battery. Now the negative lead on this battery runs out to the magnet. So basically what you're doing in this setup is you're taking two 12-volt batteries, running them in series, and if they were charged, you would get 24 to 25 volts. These batteries aren't completely charged. It is cold today. I want to say I think the feel like is roughly 20 degrees. So the batteries are a little undercharged. It's not a big deal. So what I'm going to show you here is I have a piece of 2-inch by 1-inch solid bar. It's roughly 5 feet long. So what I'm going to do is I'm going to set this magnet up. Well, I'm going to set my phone up so you guys can actually see what I'm going to do. And I'm going to show you that with some wire, some ingenuity, some time, you can actually make these at home. They're not that difficult to make. They are time consuming, but they're not that complication or difficulty. They're not that hard. So what I'm ultimately trying to do here is, as I stated, I did a lot of scrap metal. So I'm trying to create a magnet that would be good for my skid steer, be able to pick up scrap metal, little bits, nuts, bolts, hardware, little bits of beam, some things like that. So I am going to attempt to set my phone up so you guys can actually see what I'm doing, and I will show you how strong this really is with roughly 21 volts. So if I can get this set up here. All right, hopefully this doesn't fall over. Okay, so right now you see the magnet and the steel bar. So basically what I'm going to do now is I'm actually going to energize the magnet. I'm going to put the steel bar against the magnet, and then I'm actually going to stand on it. And it should hold my weight without a problem. And obviously the higher voltage you have, the stronger it's going to be. You're going to want to make sure you use DC voltage only for this style of magnet. So the magnet is now energized, and as you can see, there's nothing holding this bar on here. Let it go, bar comes off. So it's definitely a working magnet. So I have the bar back on here again, and let's see here. That is 100% of my weight on that bar. I'm not holding on to anything else. All I'm doing is balancing myself on the engine stand so I don't fall over. But that is 100% of my weight. Now, as you can see, when you de-energize the magnet, bar falls off. You can do this at home. I would suggest to actually understand electromagnetic principles, and you're going to want to know, obviously, some electrical principles, so on and so forth. If you completely don't know any of this, then feel free to comment, feel free to message me, and I will help you out. I can help you make something similar at home. I can help you with designs. I mean, it's not really that difficult. So right now, I'm roughly 230 pounds, and that was 100% of my weight on that bar. So basically, what I'm saying is I don't have any more weight here that I can hang off of this magnet to find out what its actual pull strength is. Something else I want to point out that I've learned is, let me see, where's my bar? Okay. As I said, that was 1 inch thick bar. I use this is an 1/8 inch square tube. It's a 3x3 1/8 inch square. When I use that tube, it would not sustain my weight. So one thing you have to understand is that the density of the metal makes a huge difference. The thinner the metal, the less the magnet's gonna pull to it. So you have to be aware that if you're trying to pick up thin metal, you need to have a very, very, very large magnet that has a lot or a very large magnetic field. The larger magnetic field is created by the number of turns around the core. The smaller the core, the less magnetic field it's going to create. So I would suggest get something, depending on what your ultimate goal is, to get something at least a 2-inch core. I'm actually contemplating building a magnet with a 6-inch solid steel core, and I'm actually I'm contemplating building that, and I'm hoping to do somewhere around 5,000 feet of wire. If my math is right, that will put me 25 ohms of resistance. I don't have the math in the top of my head, but that drops. The more resistance you have, the higher the voltage you can run, higher DC voltage you can run through the magnet, thus producing a larger magnetic field. If you have 2 ohm or 3 ohms, which is what this magnet is at 12 volts, that is roughly 4 amps, take or give. And that wire is more than hefty enough to withstand 4 amps at 12. I think I actually did 13.5 volts. So you have to find that sweet spot between your amperage, your voltage, and your resistance, and then you can actually figure out what your total voltage is that you can run through that without burning the wire up inside the magnet. The other thing you have to take into consideration is it's basically it's a short. I mean, that's really all it is. So you're losing, you're basically turning your DC voltage into heat that is generated, and you're turning it into the magnetic field. Majority of your energy is going to be dispersed as heat. So you have to be aware of that. So if you're running a magnet, if you run a magnet constant at basically 100% duty cycle, suggesting obviously if you have a constant power source that's not going to die, you do have to be aware that those windings and the magnet internals are actually going to start getting pretty hot. So you're not necessarily just worried about your amps, your volts, your resistance. You have to be aware that if you're using wire like I did, you have to be aware of what the insulation is rated to temperature wise before it starts getting soft or even starts melting off. Because if you get a short in there, your resistance is going to change, your magnetic field is going to change, it's going to dwindle, and I mean, you could really get into a bad situation. So that's just kind of what I've been working on the last day or two. Hopefully, when the weather gets a little bit better, I will be able to actually go out and test this with the skid steer, try and pick up some steel, see if I can pull some nuts and bolts out of the ground, just some stuff like that, and see if it's going to work for what I'm doing. All right, so now I have the batteries in series. This will produce, if they're fully charged, this would produce about 24, 25 volts. So what you see I have here is I have, we'll call this battery number 1. I have the negative wire running to the ground, and I have the negative wire running to the relays. The reason I did that, these are 12 volt relays. I don't want to put 24 volts on these and fry one. On the positive side, you see I have the wire running to the negative side on battery number 2. And you see I have a positive lead that I'm using to energize the solenoid. Now on the positive side of battery number 2, I have the wire coming off, going into the circuit breaker, thus runs to the relay. So I'm going to set this back up here. Okay, so now what I'm going to do is I'm going to energize the electromagnet, and you should be able to hear a distinct difference when this metal bar gets pulled to the magnet. It should be a little bit louder and more of a solid clunk. So it's now energized. So yeah, that's energized. That's not coming off. When you de-energize it, as you see, it will. So if my math is correct, at 24 volts I should be running roughly 8 amps. At 12 volts I should be running about 4 amps, if I'm correct. I'll have to go back and I'll have to check my spreadsheet. Basically I've logged all my magnet experiments and everything else. So that's kind of where I'm at. I think I'm going to take a break for now, and I will probably upload another video once I get everything set up on the skid steer and actually be able to do some, in my opinion, some actual real world testing for something that I would use it for. What someone else would use this setup for, I mean, there's thousands and thousands of uses for electromagnets. I mean, electromagnets are used in everyday life. An electromagnet is half of a AC transformer, which transformers are in damn near everything. You'll find them in TVs, kitchen appliances, your vehicle. I mean, welders. They're all over the place. So this isn't something new. This has been around for a very, very long time. I'm just trying to show you how simple it is to actually make these things and to be able to use them for your needs. Maybe I've sparked one of your ideas, or maybe I've helped you progress in one of your projects. If I have helped you with that or given you some helpful information, drop a comment, let me know. I appreciate it. It's nice to know that what I do helps inspire someone else or helps someone get to the next step in their project. So I think that's going to be it for this video. I appreciate you guys coming by, checking out my channel. And I'm not usually one for this, but I would appreciate if you subscribe to the channel, and if you click the notifications, you'll get notified of every time I upload a new video. And I appreciate the support. I appreciate you coming out, watching the channel, and seeing what I do in my spare time out here in the middle of nowhere. So I appreciate it, guys. You guys have a good day, and we will see you during the next video.